I've written some overloads of the comparison operators so that you can take a look at how they're actually coded. First though, I want you to see how they're used because it's pretty simple and intuitive. I've got two people here, P1 and P2, and if you remember how these objects work, they have a first name, a last name, and an arbitrary number, and these constructors are setting their arbitrary numbers to 1, 2, 3, and 4, 5, 6 respectively. And then I'm going to test whether or not P1 is less than P2. And if it's not, I'm going to print out the word not. So this will pump out either P1 is less than P2 or P1 is not less than P2. And if we look at the values, if we're going alphabetically, K is before S in the alphabet. If we're going by numerical value of the arbitrary number, 1, 2, 3 is less than 4, 5, 6. So I'd expect this to print out P1 is less than P2. Now I'm going to compare P1 to a number, an integer, 300. That sort of tells us just by reading the code that it's probably the arbitrary number that's being compared. Pretty much the identical code except it says 300 here instead of P2. Well, 1, 2, 3 is less than 300, so I'm guessing to see that this would say P1 is less than 300. And then we flip it around and ask, is 300 less than P1? This isn't just about getting the opposite answer. As you saw on the slide, this also means we actually get a different function called. So when the compiler needs to deal with this line of code, it's going to call a function which is a member of the person class called operator less than that takes a person as its single argument. When it comes time to deal with this line of code, it's going to call a member function of person called operator less than that takes an integer for its single argument. When it needs to deal with this line of code, it can't find a member function of integer, so it's going to look for a free function called operator less than that isn't in any class at all, whose first argument is an integer and whose second argument is a person. And as the person developer, you sort of have to cross your fingers that nobody else feels like writing that function. I've written those three and I've declared them all in person.h and implemented them all in person.cpp. So let me show them to you now. The two member functions, one that takes a person and one that takes an integer, are inside the person class. I've defined these as member functions of person. So person class starts here, ends here, and these are public member functions. Now I decided to make this one take a person reference rather than a person. When we were talking about functions and about passing by value versus passing by reference, it's a little quicker to pass by reference. In fact, there are a series of idioms and patterns that we use when we're writing operator overloads, and we use references for a number of reasons. Actually have a pattern to use const reference, but since we haven't talked about const yet, I'm not going to bring that in, but I have written it to take a person reference. And this one takes an integer. The third function, same name, operator less than, same return type, bool, but it takes two parameters, the integer first and then the person, and that's the one that's used in this comparison here. Now the three functions are all implemented in the person.cpp class. There's no particular rule about where you have to put free functions. I would never take all my free functions from throughout my application and stick them all in one big file called functions. This overload, it may not be part of the person class, but it should be maintained by the person developer. It should be written by someone who knows how person works, and it really belongs in person.h because anyone who includes person.h is probably going to need this function. And similarly, the code for it belongs in person.cpp. We start with functions that you've seen before from the other demos using person. Let's come down here to the new ones. This operator less than is part of the person class. We call it by its full name, person : and it takes a person reference, and it just returns whether or not the arbitrary number of the person instance the method was called on, that is to say the guy before the operator, is less than the other guy's arbitrary number. You could have a more complicated calculation, but I have to tell you, when I look at comparison operators in the wild, they're generally all like this. They're a single line long. They say, return whether the person's salary is greater than the other person's salary. Return whether or not the order total, how that compares to the other order's total, or the ship date, or the due date, or some other single variable. Sometimes you might see a little tie breaking or a tiny bit of a calculation, but it's common as dirt for these comparison operators to be just really one line of code. The one that takes an integer, so we were saying if P1 is less than 300, just compares the member variable of the instance that was before the operator to the number. And the free function, notice its name does not start person : : it just compares the two parameters that it was given. In this case, the integer and the arbitrary number of the person. And you see I'm using this public function, getNumber. That's because this operator less than is a free function. It's not in the person class. It can't access arbitrary number directly. Arbitrary number is private. So I have to use this public getNumber. Let's run this to show that it works. P1, which was 1, 2, 3, is less than P2, which was 4, 5, 6. Yep. P1 is less than 300. Yes, 1, 2, 3 is less than 300. And 300 is not less than P1. Also correct. So all of these operators work. It's a good sign. As a rule of thumb, if you're going to implement less than, you should probably also implement greater than. You should consider implementing less than or equal to, greater than or equal to, is equal to, and so on. People will be very confused if they can only use one operator and not all the rest of them. And it's quite common to implement these in terms of each other. I'm not going to show you all of that just in the interest of time. I do want to consider the possibility, what would you do if there was no public getNumber function in person? This is a completely fake and arbitrary thing, so we stuck a public function in it a long time ago for demo purposes. But it's quite common to write business objects that do not reveal their individual components. If there's a business need for it elsewhere within the application, then you would add that public function. But there may not be a business need for it. Would you add a public getNumber function for no other reason than to let this operator work? And if you didn't, what would be your alternative? Well, in C++, and many other languages don't give this capability, there is a way around this. And the motivation for having a way around it has to do with this unfortunate circumstance that some of your operator overloads have to be free functions. They have to be free functions because you can't go into integer and add a method to it. But really, emotionally, spiritually, if you will, this is part of person. It's here in the same files as all the rest of the person code. It's written by the same developer. And yes, if I change this variable's name, I'm going to have to rewrite all the person code. I get that. And you know what? I'll rewrite this at the same time, right? Given that, I can make an exception to the public-private rules for this particular function. I can copy this line, come up here and say friend, and then paste the line. This doesn't declare a function. I still have to declare it down here. What it does is it says this is an exception to the rules about what is private and what is public. It doesn't make operator less than that takes an integer and a person somehow a member function of person, but it does give it those privileges. And once those privileges have been given to it, instead of calling this public function getNumber, I can use this private arbitrary number, and I'll just build this to prove to you that it compiles. And indeed it does. Without the friend statement, I get error messages, basically saying I can't access that private member arbitrary number. So the friend statement was what made the exception and that made it possible for that operator to access the private variable. You may have heard that the friend keyword in C++ breaks encapsulation, and there's no denying it, it does. There I am letting a free function that is not part of person access person's private member variables. But it's not part of person because of a quirk of the way the compiler has you write overloads. We've got the header for it here in person's header. We've got the code for it here in person.cpp. And if someone comes along and changes the design of person, there you have a to-do list of things they need to fix. They need to fix all of the methods that are already in person, and yeah, they need to fix this one too. And in case they don't happen to see it down here after the end of the class definition, they'll certainly see it here. This friend forms your to-do list if you happen to change some of the private insides. The friend keyword has other uses that are less defendable than this one. This is 100% A-okay. It's less okay when you have two classes that share a lot of work and golly, this is annoying writing these get things, I think I'll just make them a friend. That's generally a sign that you have misdesigned your pair of classes. Don't let what people tell you about that use of friend mess up this use of friend, which is entirely appropriate and a good practice. If you're writing an operator overload, the only way to write overloads where your type is not before the operator is to write free functions. And in many cases, if you don't have public functions available to write those free functions with, you're going to use the friend statement to gain access to the private member variables. It's not wrong. But let's focus back not on the complexity of the friend statement, but on the simplicity of this code. Because you take the time to write those overloads, which are admittedly a little funny, operator less than is a weird function name, you get this super readable code that uses your object. You put a little effort into writing your class, and now the code that uses your class makes perfect sense. As much as it can make sense to ask whether one person is less than another based on the value of an arbitrary number. But imagine you're doing something real, dates and purchase orders and things. Using the less than here is more readable and more understandable than using a member function like compare or is less than, all spelled out, ISLESSTHAN. I love operator overloading. It puts a little effort on the author of a class, but produces very compact and readable code, which is a good. There's no denying it. C++ has a lot of operators. Arithmetic operators, including things you may not have heard of or that may not be in other languages you know. Very specialized operators that were originally brought in for performance reasons, and that remain because they are concise and they can express your intention without you having to write a lot. I equals I plus 1 or I plus plus. When you're working with I, it's kind of the same, but when you're working with long variable names, it's not the same at all. There are some traps waiting for some people. The double ampersand versus single ampersand, people accidentally using bitwise operators when they mean to use Boolean operators. People using Boolean operators and not realizing that they shortcut. And people mixing up the equality comparison operator, two equal signs, with the assignment operator, a single equal sign. A single equal sign is not going to trigger a warning or error message for you. It's often the right thing to do inside an if, but you need to be confident whether you really meant to do it or not. The suite of operators that C++ has lets you write incredibly concise, readable code, and it lowers the burden on developers to remember how to do things or what things are called. And that's especially true when you combine operator overloading. It's simply easier to remember the plus sign than whether something is called add or append or increment. It's easier to remember the less than operator than whether it's called compare. And having less than return true or false is more memorable than having compare return -1 if it's less, 0 if they're the same, and +1 if they're greater. Using operator overloading puts a tiny more burden on the developer of a class, and it really is only a tiny more burden. After all, writing a function called ADD or writing a function called operator plus, not that different. And yet the user of your class gets the ability to really think of your type, date or string or purchase order or employee, just as a thing, just like an integer or any other fundamental type. I think you've already seen that because string is a class. It's not a fundamental type, but I bet in your head it already feels like it's just a type, the same as integer. And date can be that way too, and if the author of the class puts the work in, so can employee or purchase order or insurance policy or whatever it is your application is all about. Once you get into templates, you'll see even more how this fundamental similarity between, say, an integer and a string, between a floating point number and a purchase order, enables you to write very interesting generic code in a way that can't be done in other languages. For now, understanding the wide variety of operators that C++ offers and how you can be part of it by writing your own overloads of those operators, it's a good addition to your C++ knowledge.